Okay, now that we've been looking at correlations, let's take a few minutes to look how correlations become useful for us and also how to think critically about using them so we don't make common reasoning errors drawing from correlations. So, the value of my r-squared is the proportion of the variation y that is explained by the linear relationship between x and y. This allows us to explain and understand the past, and, when used appropriately, can also help us predict the future. So we can use that linear equation that's expressing the relationship between y in terms of x to predict future values of y for any given value of x. This opens up the possibility of altering y, an outcome, through manipulation of x, some other variable that's closer to us in time that we can affect. So this is where we're not really going into that in the class right now. We're going to stick basically with basics of correlations, but just be aware that being able to use correlations is very helpful in being able to make future predictions if done correctly, and then allowing us to actually change something about value x in a hope of altering the outcome y later. Now, when we're looking at all of this, we have to have a couple of cautions that we think carefully about. So we need to think carefully about causation and directionality. We also have to think about factors involved in data collection. We also need to think carefully about reasoning data. So here we have a little cartoon which kind of gets at the heart of looking at error logics with too small a data set. So we call this extrapolating. So you're taking something from a small set. Here we are looking at yesterday. Here we have looking at today, number of husbands, and using those two plot lines and drawing a line based on just two data sets. Here humorously leads to the idea of having multiple husbands, but does get to the idea that too small a data set can lead you to make very erroneous conclusions. We need a decent, solid set of data before we can be confident in any conclusion we get from a correlation. So be very cautious of correlations done with very small data sets. Also, when we're looking at this, keep in mind about causations and conclusions that are drawn from our correlational data. So remember, linear relationships only are predicted when we're looking at correlations. So here we can see, as you did with one of your practice problems, we certainly did get a correlation line. However, when we're looking at it, we can see that it is in fact not the best predictor for what's happening for this data. It's an estimate, but it's not our best estimate because we're actually looking at here some type of curvilinear relationship. And that we need a very different type of formula for solving. In terms of looking at causality, it's also really important to pay attention to spurious correlations that can possibly be made. So here we can see an actual correlation from 2005 to 2011 looking at the number of Facebook active users, so is the number of active users on Facebook, and we also see that the Greek debt crisis was also climbing. So if you were plotting these two data pieces together, and looking at this, you'd be like, oh, well, as the number of Facebook active users are going up, right, then we see that also produces a Greek debit crisis. So that would be a spurious correlation, and indeed, even say that there's a relationship between the two would be spurious. So we need to be very careful making sure that when we're linking two variables, just having any two things that as one changes, the other changes is not necessarily evidence of an effect. Keeping in mind, when we're looking at this, we can look at terms of actually is one driving the other or not, or you can have completely spurious correlations. They're two things. So they're both changing at a similar rate in a similar amount of time, but that alone does not mean that they are actually related to each other. Now, with that said, we need to take a few moments and also think about when we do use causations and how do we use them for detecting real relationships. This is very important. It's very common for novice users of statistics to dismiss any correlation as going, oh, well, it's just correlation. It could be anything. We don't know anything about it. You can't make any conclusions from it. Well, first of all, keep in mind, any single study, whether it's a correlation, a t-test, an ANOVA, any of these, we can't make a conclusion from that single study, right? So it supports an argument, but it certainly doesn't prove it. However, when we're looking at correlations, we have to be more careful with that, but we can look at with a series of studies detecting authentic causation. This is really important when we're looking at issues that we are not actually ethically or logistically able to manipulate. So here's a good example from the studies that were designed to look at smoking and lung cancer. So If you go through and you're looking at the research done on smoking and lung cancer, in terms of drawing correlations, that research over a series of years met all of these criteria. So here's the things we need to have if we're going to detect an authentic causation using correlational data only. So first of all, the effect must be substantial. So it's got to be 5 to 10 times more likely. Anything less than that, and we're not going to have confidence in it. We also need to be having it consistent across multiple studies, which of course is true for absolutely any type of research. You always have to have it consistent across multiple studies. Secondly, it needs to be specific. So we need to specify, in this particular example, specific parts of the lung that are being affected by it. It's not enough to make a global statement. As they went on with the correlational studies and looking at smoking and lung cancer, they would become increasingly specific about what particular components of the lung would show change and what degree of change we would be likely to see there. It has to be temporal, so it has to be showing the change over time. We're following the same people over a period of time. It needs to be dose specific. So, for example, those that are smoking more have a higher frequency and severity of lung cancer, which is true. And lastly, it simply has to be plausible. So, when we're looking at correlation data, be careful not to throw out all data just because it's correlation and say that we can't make any statements about causation from it. We can make very solid statements of causation from a very well-designed group of studies that are interacting and interlinking together that meet these criteria. Now, the other thing we need to be careful about when working with correlations is the lurking variable. So there can be a variable that actually drives two different variables. So here we have variable A and variable B, who has a measured relationship of 0.75, which again is a good relationship, right? It's pretty strong. But when we're looking at just measuring those two, we see they're related, but keep in mind they are related. It doesn't mean one causes the other. We can have what we call a lurking variable, in this case variable C, which is actually driving both of them. So to give you an example of a lurking variable, there is a strong correlation between the number of churches in a town or city and rates of crime. Now, does that mean that church attendance causes crime? So is that what that means? So as we have more churches, then we have more criminals? Or is there something else that might be a factor that would be driving both the increase in number of churches in a town and city and the rates of crime? Well, what would be driving both of them would actually be an increase in population. So as more people are living in a town or city, you have more churches being built. You also have more people that are criminals. So this is an important thing when we're looking at variable C in this particular example would be increasing population rate, which is driving both variable A, the number of churches being built, and variable B, the rates of crime. So the last thing is looking at is paying attention to what you're measuring. So we need to think about what variables we're deciding to measure. And I'm going to pull this example from research on video games and violence. So for example, in 2015, the American Psychological Association, or APA, put out a position paper that said that playing violent video games correlate with increase in aggression and decreased sensitivity to aggression. Now, here's what's important. In the lab settings for most of these studies, aggression was measured by having the person apply a loud noise to another person. They did not control for background variables such as experience in violence in daily life, which we do know is a really strong predictor for expressing violence. Indeed, a wealth of research shows that individuals living in homes with domestic violence are much more likely to use violence and aggression themselves, and this was not controlled for in the studies. So these are design and methodological issues. One, not controlling for background variables that are a known issue. And two, we can question whether or not the lab setting of applying a loud noise to another person actually really constitutes the issue of aggression that we're interested in what we're looking at. We're not actually really looking at people being annoying, which might be the best way to describe that, but we're looking at actual violence. So a different study, Ferguson, done in 2014, went through and looked at the correlation of violent films and societal violence from 1920 to 2005. So they went through and looked at the rates of films of violence represented in films and looked at how that correlated with societal violence. So film violence pattern varied for societal violence pattern. So there was an increase in film violence in the late 20th century was actually associated with a reduction in social violence. And they found the same association pattern when focused on youth only. So one thing that's important here is that actually our rates of violent crime have been going down in the United States over the last 10 years. Now we're more aware of these rates of violent crime due to both media coverage and also, for example, Facebook postings of videos from individuals, all of which was not present previously. So when we're looking at this, it's important to pay attention to the fact that our rates of violent crime have actually been dropping off over the last 10 years. And Ferguson's study was looking at connecting this back with the pattern of violence in films. Interestingly, as rates of violence are becoming both in frequency and severity represented in films, the rates of societal violence are going down. So keep in mind that when you're looking at particular questions and issues, you're working with correlational data, you always still need to pay attention to your data that you're collecting, what background variables you're controlling for, and what specific things you're interested in. So again, looking at these lab settings, we would question whether or not applying a loud noise is really the kind of aggression that we're concerned with. Right? Or are we really looking at violent crimes? Obviously, I think we would say there's a large difference between somebody being annoying. It doesn't mean that that same person is likely to be actually physically violent towards someone else. Here in Ferguson, they're looking at violent films, so they're not looking directly at video games, but they're looking at violent films and treating those as being a similar factor. So, wrapping up looking at correlations, do be careful thinking critically about them, and as always with any analysis problem that you're using, the collection of the data is equally critical in terms of determining the quality of your overall conclusions and how well they actually predict.